Motor functions such as grasping are a basic prerequisite for our independence. If they are lost due to illness or injury, current medicine and rehabilitation reach their limits, says Dr. Matthias Ponfik, who works daily with paraplegic people.
The
current therapeutic strategies that we have, or treatment pathways, often don't manage to restore, for example, a grasping function. And that's where it's very interesting to have high-level scientists on your doorstep doing research in bioinformatics, engineering, robotics, and AI systems to bring these to the patient.
Der Robotik natürlich forschen und dann natürlich auch KI-Systeme, das eben an den Patienten zu bringen.
The neurologist is talking about the Assistive Intelligent Robotics Lab at Friedrich-Alexander-Universität Erlangen-Nürnberg. Here, researchers want to take the functionality of robots and exoskeletons to a new level.
What we do in this laboratory, the Assistive Intelligent Robotics Lab, is we try to make assistive robots more friendly so that they can be used directly by patients in the future, maybe even without the assistance of anyone else. We employ existing extremely new technologies such as these robots here, or very advanced prostheses, exoskeleton for walking or for rehabilitation of the upper limb, 3D printing, virtual reality. We do a lot in virtual reality, and we try to make these machines adapt to the patients.
His colleague, Professor Alessandro Del Vecchio, focuses on the derivation of neuronal muscle signals to control exoskeletons, and the unique research results give reason for hope, even for severely paralyzed individuals.
Our analysis is focused on the identification of spinal motor units, which are cells that are located in the ventral horn of the spinal cord. And these cells are very important because they convey the last neural code of movement, which makes us move. And we analyze this with new algorithms and also with artificial intelligent methods. We extract how the brain controls muscles. Together with Claudius and Dr. Ponfik, we are now using these methods in humans with spinal cord injury. We recently discovered that patients that have a spinal cord injury, so they cannot move the hand anymore, for even after 15 years after paralysis, they can still modulate the neurons below the level of the injury. So for example, if a person that has the hand that is completely paralyzed, and we ask to imagine movements of the hand opening and closing, we can detect action potential at the level of the skin, just with applying sensors. Because now we can interface with the nervous system, maybe we can also find methods, for example, with assistive stimulation protocols and or mechatronic devices to even boost what is spared.
Using the smallest muscle signals to control a virtual hand or an exoskeleton with your thoughts. This possibility fascinates the hand surgeons in the plastic surgery department of the University Hospital Erlangen. The first wow moment for us was seeing how Professor Del Vecchio was able to gather so much information with a ring on his forearm that he was able to project all of the complete three-dimensional movements of the hand and fingers. Although we can't yet build a prosthesis that can do all this, a patient with this help can suddenly practice his lost function again in his head. And this is something that is known from mere therapy for pain patients. And the great hope is that the somewhat primitive replacement materials and prostheses will become so much better with the help of electrical control and better mechanics that they will be able to imitate this human function again. Even though there is still a long way to go, the goals of the interdisciplinary research group are clearly defined. We also have planned the project where we want to build a new prosthesis. The one thing is to collect information and make it available for the prostheses. The other is, of course, to build appropriate prostheses that also have more joints and adequate degrees of freedom.
If I need to think of this lab, this group, in the turn of 10 years, I would expect to have a real potent impact on the way assistance and rehabilitation is managed in this area, and then possibly even in the remote future in Germany and in Europe.